It began with a world so distant that sunlight reached it as little more than a faint whisper. Nearly 4 billion miles from Earth, a tiny frozen dwarf planet was quietly doing something no one thought possible. Instead of simply sitting in the deep freeze of the outer solar system, Pluto was using the bluish haze floating through its own atmosphere like a giant, natural refrigerator, cooling itself in a way scientists had never seen anywhere else. It sounded impossible. Yet decades of exploration would slowly reveal that this lonely world had been hiding secrets far stranger than anyone imagined. Before we uncover how scientists discovered this incredible mystery, take a second to subscribe to the channel and help us reach our goal of 1,000 subscribers. Every subscription helps us continue bringing you carefully researched space stories based on real scientific discoveries. Now, to understand how this astonishing discovery became possible, the story has to travel back nearly a century. The year was 1930, and inside an observatory outside Flagstaff, Arizona, a 24-year-old assistant named Clyde Tombaugh spent his days performing one of the most repetitive jobs in astronomy. Night after night, he photographed the same small patch of sky. Then, he carefully compared each photograph, flipping back and forth between glass plates, searching for the tiniest movement among countless unmoving stars. Most evenings ended exactly the same way, with nothing new to report. Then, one cold February day, everything changed. A tiny point of light had shifted ever so slightly against the background of distant stars. That tiny moving dot was Pluto. Almost overnight, the mysterious object became the 9th planet of the solar system. Although it was unimaginably distant and far too small for telescopes to reveal anything more than a blurry speck, Pluto captured the imagination of people around the world. For generations, it remained a symbol of the unexplored frontier at the edge of the solar system, even though astronomers could only guess what the world actually looked like. Then, 76 years later, another moment changed Pluto's story forever. In 2006, the International Astronomical Union voted to redefine what qualified as a planet. When the decision was announced, Pluto lost the title it had carried for most of the 20th century. It became officially known as a dwarf planet, making it the only world in modern astronomical history to be discovered as a planet, celebrated as one, and then formally removed from that category by an official vote. To many people, that seemed like the final chapter. Pluto was dismissed as a small, distant object with little left to teach us. But nature had a very different ending in mind. Before any spacecraft ever reached Pluto, humanity knew remarkably little about it. Throughout most of the 20th century, even Earth's largest telescopes could see it only as a tiny, blurry point of light. Astronomers could calculate its orbit with reasonable accuracy because its movement across the sky could be tracked over time. But almost everything else remained uncertain. No one knew exactly how large it really was. No one understood what covered its surface. Even the existence of an atmosphere remained a mystery. Some of the earliest scientific estimates were dramatically wrong. Researchers once believed Pluto had to be much larger because they thought its gravity was affecting the orbits of Neptune and Uranus. Years later, those supposed gravitational disturbances turned out to be nothing more than measurement errors. In reality, many of the beliefs people accepted about Pluto for decades were built on assumptions layered upon assumptions. That uncertainty made what happened next even more extraordinary. In July 2015, after spending 9.5 years crossing billions of miles of empty space, NASA's New Horizons spacecraft finally reached Pluto. It was a mission unlike most others. There would be no orbit around the dwarf planet. There would be no opportunity to return. The spacecraft had only one chance, a flyby lasting just a few precious minutes, to gather as much information as possible before disappearing forever into the darkness of the Kuiper Belt. Every image and every measurement mattered. When the first photographs arrived on Earth, they transformed Pluto from a distant mystery into a living world. Stretching across one hemisphere was a gigantic pale, heart-shaped plain that looked astonishingly young compared with the heavily cratered terrain surrounding it. Towering mountains made entirely of frozen water ice climbed more than 10,000 feet into a thin blue atmosphere. At Pluto's unimaginably low temperatures, water ice had become as hard and solid as rock. Elsewhere, enormous fields of frozen nitrogen appeared to be slowly circulating like a giant pot of simmering liquid, suggesting that heat was still moving beneath a crust scientists had believed was completely frozen and inactive. Above it all floated countless layers of delicate blue haze, rising hundreds of miles into space and glowing beautifully whenever sunlight passed through them. Nothing about Pluto matched the frozen, lifeless world scientists had expected to find. It no longer looked like an abandoned piece of ice drifting through space. Instead, it looked like a world that was still changing, still evolving, and still holding on to secrets that had remained hidden for billions of years. The story did not end when New Horizons sped past Pluto. In many ways, that breathtaking flyby was only the beginning. After racing across billions of miles for nearly a decade, the spacecraft had only one brief opportunity to study the distant world. It captured thousands of priceless images and measurements, then continued its lonely journey deeper into the outer solar system, disappearing into the darkness of the Kuiper Belt. There would be no second visit, no chance to circle back. Whatever New Horizons failed to see during those few precious minutes would remain hidden for years. Back on Earth, scientists found themselves staring at a puzzle unlike anything they had expected. The images revealed mountains, glaciers, strange plains, and towering layers of blue haze, but photographs alone could answer only so many questions. Research teams spent years building computer models, debating one explanation after another, yet they had no practical way to test many of their ideas. What they needed was not another picture of Pluto. They needed a way to examine its chemistry from billions of miles away without launching another spacecraft. For a long time, that seemed impossible. Then a new observatory opened its golden mirror to the universe. The James Webb Space Telescope was never designed to visit distant worlds the way New Horizons had. Instead of flying close to its targets, Webb studies the light they reflect. Every ray of light carries hidden information, and Webb can split that light into its individual wavelengths, like a prism separating sunlight into a rainbow. Those tiny patterns reveal the unique chemical fingerprints of whatever the telescope is observing. By studying nothing more than a faint pinprick of reflected sunlight arriving from billions of miles away, Webb can determine which molecules are floating through an atmosphere, measure temperatures at different altitudes, and watch how that atmosphere changes over time, all without ever leaving its position in space. Even so, observing Pluto presented a challenge that had frustrated astronomers for decades. From Webb's distant viewpoint, Pluto and its largest moon, Charon, appear extremely close together. Earlier telescopes simply could not distinguish where Pluto's heat ended and Charon's began. Scientists had repeatedly searched for evidence of Pluto's mysterious atmospheric haze, only to come away empty-handed. It was never because the haze was missing. Their instruments simply lacked the precision needed to separate the thermal signals of the two neighboring worlds. Webb changed everything. Its enormous mirror and incredibly sensitive infrared instruments finally allowed researchers to isolate Pluto's own heat signature for the very first time. At last, scientists could study the dwarf planet without Charon's signal blending into the measurements. Once Webb's instruments were fully calibrated in 2022, the telescope quietly turned its attention toward Pluto. The data that followed surprised researchers again and again. Webb did not simply deliver sharper images. it provided something far more valuable: a detailed medical examination of an entire world. Each new observation uncovered behavior that no one had expected, forcing scientists to rethink ideas that had seemed settled for years. Among the biggest mysteries was the beautiful blue haze first photographed by New Horizons during its historic flyby. Researchers already knew Pluto's thin atmosphere contained countless tiny hydrocarbon particles suspended high above the surface. What remained unknown was the role those particles actually played in shaping Pluto's climate. The answer had been hiding inside a bold theory proposed years earlier. In 2017, planetary scientist Xi Zhang of the University of California, Santa Cruz suggested an idea that sounded almost backwards. On Saturn's giant moon Titan, thick atmospheric haze traps heat, acting like a blanket that keeps the surface warmer than it otherwise would be. Zhang wondered whether Pluto's haze might behave in exactly the opposite way. Instead of trapping heat, perhaps those tiny particles absorbed sunlight during the day and then radiated that energy back into space as infrared light faster than Pluto's paper-thin atmosphere could retain it. If that idea were correct, Pluto's haze was not warming the dwarf planet at all. It was cooling it. The haze was acting less like insulation and more like a giant radiator, quietly carrying precious heat away from one of the coldest worlds in the solar system. Many scientists considered the proposal intriguing but difficult to believe. More importantly, there was no instrument powerful enough to test it. For years, Zhang's hypothesis remained nothing more than an elegant possibility. Then Webb finally provided the missing evidence. Using Webb's powerful mid-infrared instrument, astronomer Tanguy Bertrand and his team at the Paris Observatory measured Pluto's atmosphere with a level of precision that had never been possible before. For the first time, Pluto's faint thermal signal could be separated cleanly from Charon's, allowing researchers to examine the dwarf planet's atmosphere on its own. The observations would soon reveal that the strange idea proposed years earlier was astonishingly close to the truth. When the research team finally finished analyzing Webb's observations, the results were even more remarkable than anyone had hoped. In June 2025, the findings were published in the journal Nature Astronomy, and they confirmed almost exactly what Xi Zhang had predicted 8 years earlier. Pluto's upper atmosphere was not simply cold because it orbited so far from the Sun. The tiny haze particles suspended high above the surface were actively cooling the atmosphere itself. The measurements revealed that Pluto's upper atmosphere was roughly 30 degrees Fahrenheit, colder than previous scientific models had predicted. It was the first direct evidence that the strange blue haze surrounding the dwarf planet was behaving like an enormous natural cooling system. For decades, scientists had thought of atmospheric haze as something that trapped heat. On worlds like Saturn's moon Titan, thick haze acts almost like a blanket, helping keep the surface warmer. Pluto had completely rewritten that rule. Instead of holding heat in, its haze absorbed sunlight and then radiated that energy back into space so efficiently that it actually cooled the atmosphere surrounding it. It was as though the dwarf planet had built its own natural refrigerator. Researchers now describe Pluto as possessing an entirely new type of climate, one unlike any atmosphere previously studied anywhere in the solar system. The discovery reached far beyond Pluto itself. Scientists immediately began asking whether similar hazes might also be quietly controlling the climates of other distant icy worlds, including Neptune's moon Triton. Some researchers even wondered whether Pluto's unusual atmosphere might offer a glimpse into Earth's own distant past, revealing processes that could have existed billions of years ago, long before oxygen transformed our planet's skies. Yet the strange haze had another secret waiting. Unlike the dramatic cooling effect, This second discovery happened so slowly that it would be almost impossible to notice unless someone watched it for millions of years. Even the incredibly weak sunlight that reaches Pluto is still powerful enough to break apart methane molecules floating high in the atmosphere. Those shattered molecules do not disappear. Instead, they slowly reconnect with one another, forming larger and increasingly complex compounds through an endless chain of chemical reactions. Eventually, those reactions produce reddish-brown particles known as tholins. Like tiny snowflakes, the particles drift gently downward through Pluto's atmosphere until they settle across the frozen landscape below. New Horizons first detected signs of this process during its historic flyby in 2015, and every new observation since then has helped scientists understand the chemistry in greater detail. The implications are astonishing. Tholins belong to the same broad family of complex organic molecules that many scientists believe may once have fallen onto the young Earth billions of years ago. Some researchers think those compounds may have supplied part of the raw chemical material that eventually helped life begin on our own planet. On Pluto, that same process appears to have continued almost uninterrupted for roughly 4 billion years. For billions of years, complex organic molecules have quietly drifted through Pluto's atmosphere like an endless snowfall. They land on the frozen surface one grain at a time, but nothing more ever happens. The world is simply too cold. Those chemical building blocks accumulate year after year, century after century, billion after billion years, preserved inside a deep freeze where they can never take the next step toward becoming life. To appreciate just how hostile Pluto truly is, the numbers tell an extraordinary story. The sunlight reaching Pluto is about 1,000 times weaker than the sunlight illuminating Earth. Even at local noon, the landscape would resemble the dim light of twilight rather than daytime. Surface temperatures usually remain between approximately minus 387 and minus 369 degrees Fahrenheit. That is more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At temperatures like these, nitrogen, the same gas that makes up most of the air surrounding you right now, freezes into solid ice. The atmosphere that allows every breath you take would simply become part of Pluto's frozen ground. This is exactly why scientists find Pluto's chemistry so fascinating. Researchers studying the origin of life have debated for decades where Earth's earliest organic molecules actually came from. Did those compounds form naturally on the young Earth itself? Or were at least some of them delivered from space aboard comets, asteroids, or icy worlds, where similar chemical reactions had been taking place for billions of years? Pluto offers scientists something incredibly rare. Instead of trying to reconstruct an ancient process that ended on Earth billions of years ago, researchers can watch a similar chemical laboratory still operating today. Every observation made by Webb allows scientists to witness complex organic chemistry unfolding naturally on a real world, almost exactly as it may have unfolded long before life ever appeared on Earth. In that sense, Pluto is no longer simply a distant curiosity at the edge of the solar system. It has become one of the closest things humanity possesses to a living record of the chemical conditions that may have existed before life itself ever began. For scientists, that is what makes Pluto so extraordinary. Instead of trying to reconstruct ancient chemistry from scattered clues left behind on Earth, researchers can watch a similar process unfolding in real time on another world. The reactions that may have helped shape our own planet billions of years ago are still taking place on Pluto today, quietly continuing without interruption. That gives scientists something they could never recreate inside a laboratory. It provides a natural experiment that has been running continuously for nearly 4 billion years. On Earth, those early chemical processes disappeared long ago, leaving behind only fragments of evidence buried deep within ancient rocks. Pluto, however, still preserves them in action. Viewed that way, Pluto is no longer just another frozen object orbiting at the edge of the solar system. It has become one of the closest things humanity has to a working model of the chemical environment that may have existed before life ever emerged anywhere. But, as remarkable as that discovery was, another mystery waiting on Pluto proved even more surprising. For billions of years, Pluto has been slowly disappearing. Not all at once, but molecule by molecule. High above the dwarf planet's frozen surface, methane and other lightweight gases constantly drift upward through its extremely thin atmosphere. Eventually, some of those molecules move fast enough to escape Pluto's weak gravity altogether and begin a slow journey into space. Astronomers had suspected this atmospheric escape for many years. The real mystery was what happened after those molecules left Pluto. For a long time, researchers assumed they simply disappeared into the emptiness surrounding the dwarf planet. They were wrong. Someone, or rather something, had been collecting them all along. That something was Pluto's largest companion, Charon. Nearly 750 miles across, Charon is no ordinary moon. It shares an unusually close gravitational relationship with Pluto, so unusual that neither object truly circles the other in the way Earth and its moon do. Instead, both worlds orbit a shared center of gravity, locked together in an endless cosmic partnership. At first glance, Charon appears rather ordinary. Its surface is covered mostly with ancient water ice, scarred by countless impact craters accumulated over billions of years. Yet one feature immediately stands out. Its polar regions are stained a deep reddish-brown, far darker than anything else visible across the moon's frozen landscape. For years, scientists suspected those dark caps were somehow connected to Pluto's escaping atmosphere. What they lacked was direct evidence. Eventually, researchers discovered that the answer lay in Charon's remarkably long seasons. Because of the moon's unusual tilt, its northern polar region spends decades at a time in complete darkness. During those long polar winters, no sunlight reaches the surface at all. Those conditions transform the pole into an enormous natural cold trap. As methane molecules escape Pluto and drift across the roughly 12,000 miles separating the two worlds, Charon's gravity gently captures some of them. The extreme cold causes the methane to freeze immediately upon reaching the permanently shadowed surface. Year after year, decade after decade, more frozen methane slowly accumulates. Then, eventually, sunlight returns. But instead of simply warming the frozen methane until it evaporates, something much stranger happens.